So this is how the question goes. So the language is that the word is such that the word's final digit has appeared before. That's for the I. So now this is the solution I made. So we should know that the language consists of so something like 00. The last digit has appeared before. So you see, 0 has appeared once, it has appeared again. That's the final one. 1 has appeared again. You see, we can even have 3 zeros. That's the first one 0, then the final one is still 0. It has appeared before. So any number of zeros or ones or any number between still will work. So we can have 9019. So this is how I derived the solution. So at Q0, when we see 0, so it will actually have, if you are to look at it, you will see I made some ellipses between the side here. So the ellipses is because I have to do it for 0 up till 9. So 0, 0, 1, 2, 3, 4, 5, 6, up to 9. You see, that's why I'm putting the ellipses there. So if we see something like 0, 0 from our language, 0, 0 should be accepted. So 0 comes here, Q1, then 0 again is accepted. Now what about 1, 1? 1, 1 is accepted. What about 1, 0, 1? 1, 0, 1 should not be accepted. 1, 0, you see, 1 can't go anywhere. So first of all, you write your language and you design this out of it. So something like 3 zeros. So 0, 0, 0. It should be accepted. 0, any number of you can have 0, 1 or 2 or 3, anything here is recurring. So 0. Now when it sees 0 again, it's accepted because the final one should be a 0. So you should get this. So that's the design of this. So actually between the side there's about, so if you check, you see I use Q1, Q2, and now here I put Q10 there because we can have Q3, Q4, Q5 up to 10. So that's for the first one. The second one, the language should be such that the language should be a set of words, that strings, such that the string is over alphabet 0 to 9, such that the final digit has not appeared before. So has not appeared before too. The language will be, it can contain, let's say 0, 1. You see the last 0 has not, the 1 has not appeared before. The thing is the string is of length to 0 and 1. Then we've seen 0, we've not seen 1 before, so it should be accepted. We've seen 1, we've not seen 0, it should be accepted. 9, 1, you see 8, 9, 0 itself should be accepted because it hasn't seen any other thing different before. You should get it. So let's compare it with this. So if you are to look at this, the sigma here is used to represent alphabets. You should know this by now. Epsilon, sigma is used to represent alphabets. So you see, even here you can see you can see here that the alphabet was 0 to 9. That's the sigma. So even here I could have used sigma to represent 0 to 9, but I didn't think about that till I came in. So here okay, so how I did it, so I said something like 0, 1 should be accepted. So 0, okay, when it takes this part, 0 will not go here. It can transition from Q0 to Q1 upon seeing anything apart from 0. Apart from 0. So if it sees 1, it will transition. So it should not be the 0 itself. I want to use the first example, so let me use this route. So you see Q, the language contains 0, 1. 0 1. So here you get 0. It can go because here it contains 0 up to 9 except 1. So we can take this route. So 0 will come here, and now 1 will come here. It's accepted. You see, it shouldn't, the last digits should not have been seen before. So that's why it looks like this. So a number like 0 itself, 0 should also be accepted because it has not appeared before. Sorry, what was the question, sir? He said yes, the final has not appeared before. So 0 here, 0 should pass this route because it has not been seen before. So that's why I made a separate part for the single digits. So it can be 0, it should be accepted. 1 should be accepted. Any single digit should be accepted because it has not been seen before. Okay, last one. L equals, so the language is a set of words or strings such that the string over the alphabet 0 1 has 2 zeros separated by a number of positions, that is a multiple of 4. So the number of positions can be 0. From the question, if you had to look inside, you wrote something like 0 is an allowable multiple of 4. Yes, 0 divided by 4 equals 0. A multiple. Yes. So you can have 0, 4, 8, 16. So in these positions, so the language was, it can be 0, 0. You see, it should be separated by 2 zeros. So here, the number of positions, the multiple number of positions between is 0. There's no position between. 0 is a multiple of 4. Here, the number of is separated. There are 2 zeros. Then it's separated by 4 zeros. You see, this is the number of positions, 4 zeros. Here, separated by 4 ones. Here, separated by 8 zeros. Separated by 8 ones. It should still be accepted. So we can go on and on, moving to separated by 16, separated by, you see, multiples of 4. So how I did it was that now we are here. So let's take our language. 0 0 should be accepted. So Q 0 0 is a Q 1 0 is now accepted. Now what about so yes, what about something like, so you see here we didn't put a recursion here because it should start with 0 is by force and end with zeros, and it should be what? Yes, it should have, for something, a multiple of 4 positions between it. So something like 0, 2 zeros separated by 4 zeros. So here the sigma is 0 and 1, as you saw. So it can be 0 or 1. I could have just written 0 or 1, but Charlie. So 0 and 4 zeros. So 1, 2, 3, 4 is here, and now 0 again. You see, it's accepted. Now position, that's, let's say it's 1 1 1 1. So 0 1 1 1 1 0. It should still be accepted. Separated by 4 positions. It can be 0 or 1. So here it can be 0, then separated by, let's say 0 1 0 1 and another 0. It's accepted. That's all. So that's how I got this from it.